Welcome to the AI Coach by Anil Nasu.
Great to be here.
Today, we're really diving deep into something pretty fascinating, something that's been discussed quite a bit on the AI Coach platform.
Absolutely. We're looking at the evolution of AI in education.
Exactly. Not just AI as a tool, but looking ahead, maybe even to 2025, AI becoming something that can, well, learn by itself and then, crucially, teach itself.
It's a major shift, isn't it? Moving beyond just automating tasks to AI potentially acquiring knowledge and then figuring out how to share it effectively.
Right. So our mission today is to sort of unpack that. How does an AI learn complex stuff? And then how does it turn around and explain it to, us learners?
And we're grounding this discussion in insights from the AI Coach blog, specifically Anil Nathu's piece, Learning, a comprehensive roadmap to AI-powered education in 2025. It's a really solid article.
Yeah, it lays out a great roadmap. It talks about how AI teaches itself things like reinforcement learning, self-supervised learning,
Uh-huh.
how it stores knowledge, makes learning adaptive, how you'd actually build these AI tutors, and the big picture, the future impact.
It covers a lot of ground.
It really does. Okay, so let's start with that core idea. Self-learning AI. It feels like a pretty big jump from the AI we usually talk about. What's the fundamental difference?
Well, the big departure is from traditional AI needing tons of pre-labeled data, right? Humans telling it this is a cat, this is a dog over and over.
Right, the supervised learning model.
Exactly. Self-learning AI aims to get smarter, to enhance its understanding more autonomously without needing quite so much hand-holding.
Okay, so how does it do that? What are the main ways an AI can teach itself?
There are a few key approaches. First up, there's reinforcement learning, or RL.
RL, okay.
Think of it like learning through trial and error. The AI interacts with some environment, takes an action,
Uh-huh.
and it gets feedback. A reward if it did something good towards its goal, maybe a penalty if it messed up.
So it learns from consequences.
Pretty much. Over time, it adjusts its strategy to get more rewards. It's constantly trying things out, seeing what works, and refining its approach.
Like learning to ride a bike. You fall off, adjust, try again.
That's a decent analogy, yeah.
Yeah.
It discovers winning strategies through interaction, not by being explicitly programmed with them.
Can you give a solid AI example?
The classic one is AlphaGo, DeepMind's AI that mastered the game of Go.
Oh, yeah. That was incredible.
It learned largely by playing against itself millions, probably billions of times. Through that self-play, using reinforcement learning, it figured out strategies, some of which top human players hadn't even conceived of.
Wow. So it wasn't just mimicking humans, it was genuinely creating new knowledge within the game.
Exactly. That's the key insight, really. It showed AI could go beyond known human strategies and discover novel approaches. That's powerful potential for learning.
Definitely. Okay, so that's RL, learning from experience and feedback. What's another major method?
Another big one is self-supervised learning, SSL.
Self-supervised. How does that work? Does it supervise itself?
Kind of, yeah. The clever part is it doesn't need external labels provided by humans. Instead, it finds patterns and structures within the raw, unlabeled data itself. It basically creates its own learning tasks from the data.
Okay, hang on. How does it create its own tasks? Give me an example.
Think about huge language models like GPT. During training, one technique is to take a sentence, mask out a word, and ask the AI to predict the missing word.
Ah, okay, like fill in the blanks on a massive scale.
Exactly. To get good at predicting that missing word, the AI has to learn an enormous amount about grammar, context, word relationships, how language actually works.
Without anyone explicitly labeling this is a noun, this is the subject.
Precisely. It learns the underlying structure just by trying to solve these self-generated puzzles within the data. The insight is that predicting parts of the input forces the model to build a rich internal understanding.
It's like learning by observation and inference, finding the rules implicitly. That's really clever. Is there like a third key pillar to this self-learning idea?
Yes, there's also something called meta-learning,
Meta-learning.
often described as learning how to learn.
Okay, that sounds recursive. What does it mean in practice?
It means the AI isn't just getting better at one specific task, it's actually optimizing its own learning process, becoming better at adapting to new tasks more quickly, often with much less data than it would normally need.
So it learns a general learning skill.
Sort of, yeah. Google's MAML framework is a good example. It trains models so they can generalize rapidly. When faced with a new problem that's related to things it's seen before, a meta-learned AI can pick it up much faster because it's become more efficient at the learning process itself.
That could be huge for education, right? An AI that could quickly adapt to teaching a new topic or a slightly different curriculum?
Potentially, yes. It suggests AI could become much more flexible and adaptable across different learning domains without needing massive retraining each time.
Okay, so summing up the self-learning part, we've got RL learning from trial and error, SSL finding patterns in raw data, and meta-learning improving the learning process itself. The key is this continuous refinement without constant human input.
Exactly. It's about building knowledge and improving strategies autonomously.
Right. Now, the next big question, and maybe the harder one, how does an AI that's learned all this stuff actually teach it to someone else effectively? Knowing isn't the same as explaining.
That is the critical bridge to cross. Possessing knowledge is one thing, transferring it clearly and adaptively is another challenge entirely.
So, what are the key technologies or capabilities that allow AI to become a teacher?
Well, a huge piece of the puzzle is natural language processing, NLP, especially the generation side.
Like making the AI talk or write like a human?
Pretty much. Models like GPT, Claude, and others are getting incredibly good at generating human-like text, crafting detailed explanations, answering questions coherently.
We've all messed around with ChatGPT, right? Asking it to explain quantum physics like I'm 5 or whatever.
Exactly. That ability to break down complex topics, rephrase things, explain concepts conversationally, that's NLP in action. It allows the AI to communicate its knowledge in a way that's understandable.
And it can tailor the explanation based on the question you ask.
Ideally, yes. Just like a good human tutor would listen to your question and adjust their explanation. The insight is AI generating personalized, on-demand explanations.
Okay, NLP for explaining. What else is crucial for AI teaching?
Another major component is adaptive learning systems.
Adaptive learning, meaning it adapts to the student.
Precisely. The AI analyzes how the learner is doing their interactions, their answers, where they seem to be struggling or excelling, and then it dynamically adjusts the teaching. Maybe it changes the difficulty, offers more practice on weak spots, speeds up through concepts the learner clearly gets, or even changes the style of explanation.
Like Duolingo giving you harder sentences if you're doing well, or more grammar drills if you keep making the same mistake.
Exactly that kind of principle. It creates a personalized learning path, trying to keep the learner in that sweet spot of being challenged but not frustrated, maximizing comprehension and retention for that individual.
That makes a lot of sense. What about how the AI organizes all the information it knows? It must need a good filing system, right?
Absolutely critical. That's knowledge representation. It's not enough to just learn stuff. It needs to be stored and structured in a way that makes it easy to find the right piece of information and understand its context when needed for an explanation.
So it's not just a big mesh brain full of facts.
Hopefully not. We use things like vector databases.
Vector databases, like math vectors.
Essentially, yes.
Hmm.
Information, concepts, even chunks of text are converted into numerical vectors. Long lists of numbers that capture their semantic meaning.
Okay, why?
Because then the AI can find related information incredibly quickly by looking for vectors that are mathematically close in this high-dimensional space. Platforms like Face or Pinecone are built for this. It allows searching based on meaning, not just keywords.
So if I ask a question, it can find stored knowledge that's conceptually similar, even if I use different words.
Exactly. It enables fast, contextually relevant retrieval.
Clever. Is that the only way it organizes knowledge?
No. Complementing that, we often use knowledge graphs.
Knowledge graphs.
Right.
Like a mind map?
Sort of, but more structured and scalable. Think of concepts as nodes, and the relationships between them as connections or edges. So you might have a node for Python, another for function, and an edge saying Python uses functions.
Ah, I see. It maps out how ideas connect.
Precisely. Technologies like Neo4j help build these. This structure allows the AI to understand the interconnectedness of knowledge, to reason about relationships, which is vital for providing deeper explanations. Not just facts, but how facts fit together.
Okay, vector DBs for quick semantic retrieval, knowledge graphs for relationships. Anything else key for the teaching aspect?
Yes, the interaction itself, interactive learning and feedback loops. Good teaching isn't just a lecture, it's engaging. So AI teachers need to engage learners. This can be through automated quizzes, coding exercises, interactive simulations, and crucially, providing immediate feedback and corrections.
Like the Socratic app you mentioned earlier, guiding students through problem solving.
Exactly. Or think about language apps giving instant corrections on pronunciation or grammar. That immediate feedback loop helps reinforce learning and correct misunderstandings quickly. It's not just presenting information, it's actively guiding the practice.
So combining NLP for explanation, adaptive systems for personalization, smart knowledge storage, and interactive feedback loops, that paints a picture of a potentially very effective AI teacher.
That's the goal, integrating these capabilities.
Okay, let's bring this down to earth a bit. The AI Coach article, the one by Anil Nathu, points to some real-world examples where these ideas are already taking shape, right?
Yes, it's not purely theoretical. We're seeing practical applications emerge.
Like what? What are some key examples?
Well, AI-powered tutors are a big one. We're seeing systems designed to provide interactive lessons, personalized practice, and real-time help in subjects like math, science, languages.
Khan Academy's Khanmigo, using GPT, is often cited, isn't it? Offering step-by-step guidance.
Exactly. That's a prime example of leveraging a powerful language model within an established educational platform to offer more personalized conversational support.
What about other areas?
Coding assistants are another fascinating application. Tools like GitHub Copilot.
Ah, yeah, I've heard a lot about Copilot. How does that fit the learning and teaching model?
Well, Copilot has learned coding patterns from literally billions of lines of public code. It uses that knowledge to suggest code completions, entire functions, even help debug, effectively acting like an experienced pair programmer. It's teaching good practices and accelerating development by sharing its learned knowledge.
So it learned from the collective code, and now it's teaching developers in real time. Interesting. Any other examples?
Large language models themselves, like ChatGPT, are being used more directly in education. Students use them to understand complex concepts, maybe ask for explanations phrased differently, generate practice questions, get feedback on writing.
Like a study buddy or a research assistant?
Kind of, yeah. It's becoming a versatile tool for exploring topics and getting personalized help. Of course, with all the caveats about accuracy and proper use.
Sure, sure. Critical thinking is still required.
Always. And it's not just K-12 or university. Businesses are using AI for employee training, too. IBM's Watson, for instance, has been used to create adaptive corporate training programs that tailor content based on the employee's role, existing skills, and learning pace.
So personalized professional development at scale.
Exactly. It shows the breadth of application, from learning algebra to mastering a new software system for your job. The core principles of adaptive AI-driven learning apply across the board.
These examples really make it tangible. Okay, the AI Coach article also suggested we should maybe dig a bit deeper into some of those core technologies we mentioned earlier, starting with reinforcement learning, RL. Can we unpack that a bit more?
Sure. So remember, RL is about an agent learning through interaction with an environment. Key elements. The agent takes an action. The environment changes state and gives a reward or penalty. The agent's goal, maximize the total cumulative reward over time.
Right, trial and error with a goal.
Exactly. The process is this loop. Observe the state, choose an action based on the current policy, its strategy, get feedback, update the policy to do better next time. Through many, many iterations, it hopefully discovers highly effective, maybe even optimal strategies.
And you mentioned OpenAI Gym before. What's its role here?
OpenAI Gym is basically a standardized toolkit. It provides a collection of environments, everything from simple games like cart pull to complex robotic simulations. It gives researchers a common playground to develop, test, and compare different RL algorithms. It really helped accelerate RL research.
Ah, okay, a testing ground. And AlphaGo, that was RL too.
Absolutely. Sophisticated RL, combined with deep neural networks and massive compute power, allowed it to go through self-play at a superhuman level, learning which actions lead to winning states.
And RL isn't just for games, you said.
Definitely not. It's being explored and used in autonomous driving, learning navigation policies, and simulation. Complex game AI, like AlphaStar mastering StarCraft 2, which is incredibly complex, even in finance, for things like algorithmic trading or portfolio optimization, anywhere you need to learn optimal sequences of decisions in a dynamic environment.
Okay, that clarifies RL quite a bit. Now let's do the same for self-supervised learning, SSL. Remind us of the core idea again.
Core idea. Learn meaningful representations from unlabeled data by creating supervisory signals from the data itself. No human labels needed for the core learning process.
How does it create those signals again?
A common way is prediction. You take your input data, say an image or a piece of text, you somehow corrupt it or hide part of it. Maybe you mask out words like we discussed with GPT. Or maybe you take an image, crop a patch, and ask the AI to predict what the patch looks like based on the rest of the image. Or you apply different augmentations, rotations, color changes to an image and ask the AI to recognize that it's still fundamentally the same image.
So it learns by trying to reconstruct or recognize consistency within the data.
Exactly. It makes a prediction, compares it to the actual hidden piece or the relationship it should have recognized, calculates an error, and adjusts its internal model to make better predictions next time. This forces it to learn underlying patterns, structures, and features.
You mentioned contrastive learning for NLP before. Is that one of these techniques?
Yes, contrastive learning is a very powerful SSL technique. The basic idea is to teach the model which data points are similar, like different augmentations of the same image, or sentences with similar meanings, and which are different. Models like BERT and GPT use variations of predictive tasks, like predicting masked words or the next sentence, which is a form of self-supervision.
And this lets them learn language structure without explicit grammar rules fed in.
Precisely. And SSL isn't just for language or standard images. It's being used in medical AI to analyze unlabeled medical scans, learning to spot anomalies or patterns without doctors labeling every pixel. Also in speech recognition, learning from vast amounts of raw audio.
Because getting labeled data in those fields is really hard or expensive, right?
Exactly. SSL unlocks the potential of the massive amounts of unlabeled data we have in the world. It's a really important direction for AI.
Okay, got it. So RL for decision making via feedback, SSL for learning representations from raw data. Now let's revisit knowledge storage and representation. Why is it so fundamental again?
Because learning is only useful if you can access and use the knowledge effectively. For an AI teacher, this means fast retrieval of the right information, organizing it logically so explanations make sense, and understanding the relationships between concepts.
And you mentioned vector databases for the fast retrieval part. How do they work again, storing info as numbers?
Yeah, information, words, sentences, documents, images, gets converted into high-dimensional vectors, basically long lists of numbers. These vectors are designed so that items with similar meanings have vectors that are close together in this mathematical space.
So king and queen might be closer than king and cabbage.
Exactly. Then, when you search, you convert your query into a vector, and the database quickly finds the nearest neighbor vectors. Face from Meta and Pinecone are popular tools for this. It's all about semantic similarity search at
Yeah.
speed.
And the applications, chatbots, search.
Yep, chatbots finding relevant answers, search engines going beyond keywords, recommendation systems finding products or content you might like based on conceptual similarity. Very widely used now.
And the other piece was knowledge graphs. How do they complement vector databases?
While vector DBs are great for finding similar stuff, knowledge graphs excel at representing explicit relationships. Remember the nodes, concepts, and edges relationships.
Right, Python uses functions.
Exactly. This structured network lets the AI reason. If it knows A is related to B and B is related to C, it might infer a relationship between A and C. We use graph neural networks, GNNs, to actually learn and perform computations on these graph structures. Neo4j is a well-known graph database for storing this kind of relational knowledge.
So it helps the AI understand the context and connections, not just isolated facts.
Precisely. Think about Google search results, sometimes showing those boxes with interconnected facts that's powered by a massive knowledge graph. They're also used in fraud detection, finding suspicious connection patterns, drug discovery, understanding complex systems.
Okay, this deeper dive really shows the sophistication needed under the hood for an AI to both learn deeply and then teach effectively. It's not just one magic algorithm.
Not at all. It's an integration of multiple advanced techniques, pulling insights from platforms like the AI Coach by Anil Nathu to see how these pieces fit together.
Definitely. Okay, so we understand the learning foundations and the core tech. Now, let's shift focus specifically to designing the teaching mechanism. How do you actually build an AI tutor that works well?
Right. This is where we combine those underlying technologies into a pedagogical system.
A key aspects seem to be those adaptive tutoring systems. How does the AI actually personalize the learning?
It starts with assessment, basically. As you interact with the AI tutor answering questions, doing exercises, it builds a model of your current knowledge state. It identifies your strengths, weaknesses, potential knowledge gaps.
Okay, it diagnoses where you are.
Exactly. Then, based on that diagnosis, it adjusts the learning path. If you're struggling with a concept, it might offer simpler explanations, more foundational exercises, or break the problem down further. If you're acing everything, it might increase the difficulty, introduce more complex topics, or move faster.
Like the Khan Academy AI tutor recommending specific videos or practice sets based on your performance.
Precisely that. It aims to keep the learning optimally challenging and efficient for you. It's not one size fits all.
And how do the NLP models fit into this adaptive teaching?
They're crucial for generating those tailored explanations. Instead of just having canned responses, a good AI tutor, using models like GPT, Claude, or Llama, can generate explanations dynamically.
Dynamically, meaning on the spot.
Yes. It can explain a concept, and if you say, I don't get that,
Mhm.
it can try explaining it in a completely different way, maybe using an analogy or simplifying the language. It can support multimodal learning too, perhaps showing a diagram alongside the text explanation. It enables much more natural conversational learning.
Like asking ChatGPT to explain Pythagoras' theorem, and if you're still confused, asking it to explain it like you're building a ladder against a wall.
Exactly. That ability to reframe and adapt the explanation based on interaction is key.
Makes sense. What about keeping students engaged? Lectures can be boring, even from an AI,
Totally. That's where interactive learning interfaces come in. You need ways for the learner to actively participate.
like quizzes and exercises.
Absolutely. Automated quizzes to check understanding, programming exercises where the AI can give instant feedback on your code, maybe even simulations or virtual labs, depending on the subject.
Duolingo's little quizzes and sentence constructions are a good example, right? Constant interaction.
Very much so. Or GitHub Copilot, again, it's interactive because it works alongside you, offering suggestions and catching errors as you type. That real-time feedback is powerful.
So building interfaces that allow for this constant back and forth.
Yes, and implementing conversational AI effectively is part of that. Allowing students to ask questions naturally, interrupt, ask for clarification, making it feel more like a dialogue with a patient tutor.
Google's Socratic app, where you could take a photo of a math problem, that felt pretty interactive.
Right. It didn't just give the answer. It tried to guide you through the steps to solve it yourself, asking leading questions. That's a great example of interactive teaching.
Okay, so adaptive content, dynamic explanations, interactive interfaces.
Yeah.
How do these AI tutors get smarter over time? They must learn from their teaching experiences too, right?
Ideally, yes. That's where feedback and continuous learning come in. One important mechanism is human in the loop, HITL learning.
Human in the loop, involving real people.
Yeah, the AI provides an explanation or feedback, and the learner, or maybe a human expert reviewer, can rate it. Was it helpful? Was it clear? Was it correct?
Like a thumbs up, thumbs down button.
Could be that simple. Or more detailed feedback. The AI then learns from these ratings and corrections, refining its responses over time. This is similar to how models like ChatGPT are fine-tuned based on human feedback to become safer and more helpful.
So it learns from its mistakes, guided by human judgment.
Exactly. And then there's meta-learning again, applied to teaching.
How does learning how to learn apply to teaching?
The AI can analyze its past teaching interactions. Which explanations worked best for which types of students? Which sequences of exercises were most effective? It can start to optimize its own teaching strategies based on data about learning outcomes.
So it's not just learning the subject matter, it's learning how to be a better teacher.
That's the ultimate goal. Think of AlphaZero learning chess. It didn't just learn moves, it discovered optimal strategies by playing itself. An AI tutor could potentially discover optimal teaching strategies by analyzing learning interactions.
Wow. That's potentially very powerful, an AI that continuously improves its ability to teach based on results.
It's a compelling vision for the future of personalized education.
Okay, this is all fascinating, but it might sound a bit abstract or like something only huge companies can do.
Uh,
The AI Coach article actually laid out a kind of roadmap for building your own AI teacher, didn't it?
it did, yes. To make it more concrete for developers or educators interested in experimenting.
So what are the basic steps if someone wanted to try building, say, a simple AI tutor?
Step 1, according to the roadmap, is define the learning domain. What subject do you want the AI to teach? Coding? Math? A specific language, science concepts you need to scope it.
Okay, be specific. Let's say an AI Python tutor for beginners.
Good example. Step 2 is choose the learning approach. How will the AI acquire its knowledge or generate explanations? You might use reinforcement learning if it's a game-like learning environment. Self-supervised learning if you have lots of unlabeled data like code examples. Or, very commonly now, you'd start with a pre-trained large language model, LLM, and fine-tune it for your specific tutoring task.
For a Python tutor, fine-tuning an LLM sounds like a good bet for generating explanations and code help, right?
Probably the most practical starting point today, yes. Step 3, implement knowledge storage. How will it store Python concepts, common errors, code snippets, example problems? You might use a vector database like Assess or Pinecone to quickly find answers to similar student questions based on past interactions or a documentation corpus.
And maybe a knowledge graph for how Python concepts relate, like functions, loops, variables.
Exactly. Neo4j could map those relationships. Step 4. Develop an adaptive tutoring interface. How will the student interact with it? You need an API backend, maybe using something like FastAPI, and a user interface. Streamlit or Gradio are popular for quick prototyping, or maybe Hugging Face spaces for sharing.
So the plumbing and the front door for the student.
Pretty much.
Okay.
And finally, step 5. Integrate feedback mechanisms. How will the tutor learn and improve? You need ways for users to give feedback that thumbs up, down, maybe comments, and potentially incorporate some middle learning principles down a line to allow the tutor to self-improve its teaching strategies based on interaction data.
So define domain, choose learning method, set up knowledge storage, build the interface, add feedback. That makes it sound achievable, at least in a basic form.
It breaks it down into manageable steps. Obviously, each step involves significant work, but it provides a structure.
And the article also recommended some specific tools and technologies for building this.
Yes, it gave a kind of suggested tech stack.
What were some of the key recommendations?
For deep learning frameworks, PyTorch and TensorFlow are the mainstays. PyTorch is often favored for research and flexibility, especially with libraries like Hugging Face transformers for NLP. TensorFlow is known for scalability and production deployment options like TensorFlow Serving.
Okay, standard deep learning tools. What about specifically for RL?
Stable Baselines 3 is a popular library built on PyTorch, offering implementations of common RL algorithms like PPO, DQN, and OpenAI Gym, as we discussed, for the environments to train in.
And for the NLP part, the explanation generation.
Pre-trained models are key. GPT-3 or GPT-4 for powerful, coherent responses. Open source alternatives like Llama are great for research or if you need more control. Claude is known for its focus on safety and conversational ability, maybe good for language learning applications.
Right, and the databases.
FASS for fast vector similarity search, Neo4j for knowledge graphs to map those concept relationships.
And getting it all running and accessible.
FastAPI is great for building the API backend quickly. Streamlit or Gradio for creating interactive web app interfaces easily for demos or simple tutors. And Hugging Face Spaces is fantastic for hosting and sharing your models and apps with the community.
That's a really useful list of tools for anyone wanting to experiment. Okay, let's pull back now and look at the bigger picture. What is the potential future of AI in self-learning and education based on these trends?
Well, the potential is pretty transformative. AI tutors could genuinely revolutionize education by making truly individualized learning accessible.
You mean personalized learning at scale?
Exactly. Imagine every student having a tutor that adapts perfectly to their pace, strengths, and weaknesses. And this isn't just for a few privileged students. AI allows this personalization to scale to potentially millions of learners, including those in areas with limited access to quality human teachers.
Like getting math problems that are always at the right difficulty level for you.
Precisely. Plus, on-demand learning. AI tutors are available 204/7. You can learn whenever suits you, wherever you are. Great for lifelong learners, people with jobs, different time zones.
And immediate feedback. That seems huge.
Absolutely. Getting instant corrections when learning a language, coding, or solving math problems accelerates learning significantly compared to waiting for a teacher to grade your work.
It sounds incredibly promising, but the AI coach article and common sense also points to challenges and ethical considerations, right? It's not all utopian.
Definitely not. There are serious issues to navigate. Data privacy and security is a big one. These systems collect a lot of sensitive data about learning performance, potentially behavioral patterns. Protecting that data is paramount.
You don't want student weaknesses exploited or sold.
Absolutely not. Strict standards and regulations are needed. Then there's bias in AI algorithms. If the AI is trained on biased data, perhaps representing certain demographics more than others, it might perpetuate or even amplify those biases in its teaching.
So it might teach certain groups less effectively or reinforce stereotypes.
That's a real risk. We need diverse training data, ongoing auditing for bias, and a focus on creating equitable educational tools.
And the big one, will AI replace teachers?
That's the fear often voiced. Most experts see AI as augmentation, not replacement. AI can handle repetitive tasks, provide personalized practice, offer instant feedback, freeing up human teachers for the uniquely human aspects: mentorship, emotional support, complex critical thinking discussions, fostering creativity, things AI isn't good at.
So AI is a powerful tool for teachers rather than a substitute.
That's the hope and the most likely positive path forward. But it requires careful implementation and ensuring teachers are trained to use these tools effectively.
And finally, accessibility and equity.
Yes. If these advanced AI tools require expensive devices or high-speed internet, they could actually widen the digital divide, leaving behind students who lack access. Ensuring equitable access is crucial if AI education is to benefit everyone.
Lots to think about on the ethical front. So looking even further ahead, what's the next frontier? What's the ultimate vision, maybe?
The article hints at AI that learns and teaches in real time across multiple domains.
Meaning?
Imagine an AI that can seamlessly switch between teaching you calculus, then Renaissance history, then Python programming, adapting its style and content on the fly as needed. Real-time domain adaptation. Keeping pace with curriculum changes automatically.
Wow. A truly universal tutor.
And perhaps collaborative learning with AI. Not just AI teaching you, but AI working with you as an interactive learning partner.
Yeah.
Brainstorming ideas, asking you probing questions, co-solving problems, making learning more dynamic and engaging.
Like a superpowered study buddy.
Exactly. And underpinning all this, continuous improvement through AI learning. The AI constantly analyzing which teaching methods work best for different learners and different topics, observing patterns, and self-optimizing its own pedagogical strategies to become ever more effective.
Leading to highly efficient, deeply personalized education tailored to every individual.
That's the long-term vision. Ambitious, complex, fraught with challenges, but incredibly exciting.
It really is. So to wrap our deep dive today, we've journeyed through how AI is evolving from a tool to a potential self-learning and teaching entity, drawing heavily on the insights from the AI Coach by Anil Nathu platform.
We've covered the core tech RL, SSL knowledge representation, the design principles for adaptive interactive AI tutors, seen real-world examples, and considered the roadmap for building them.
And we touched on the immense future possibilities, but also the crucial ethical considerations around privacy, bias, equity, and the role of human teachers.
It's a field moving incredibly fast with profound implications.
Absolutely. So the final thought to leave you, our listener, with. Consider the implications of an AI that can genuinely learn new subjects and figure out how to teach them effectively, perhaps even across multiple fields in real time. How might that reshape your own learning journey or the future of education as a whole?
It's definitely something worth pondering.
Thank you for joining us today. Visit the AI Coach website for more AI insights by Anil Nathu.